Blower assemblies. In HVAC, we are going to run into blower assemblies on every forced air piece of equipment that is out there. That could be residential or commercial. Okay, and usually these types of assemblies, they're going to be constructed to pull air through the return air duct and filter and then push it through the heat exchanger. And if we have air conditioning on that piece of equipment, it's also going to go through the evaporator and into the supply duct. Okay, so they are required, and they do require careful design to produce enough volume and velocity to maintain the comfort at the designed conditions. The design conditions can vary. Depends on the application of the equipment that we're doing and the temperatures that we are trying to achieve. We are going to run into two types of blower assemblies out there. You're going to have your direct drive blower assembly and your belt-driven blower assembly. Okay, direct drives usually come in a variety of RPMs. Some of them can be approximately 1050 RPMs at their highest speed. However, much newer direct drive blowers are now capable of doing 3450 RPMs. Many of them are also variable speed. So we can actually have the comfort and the ability to adjust the fan speed to compensate for the velocity that we're trying to get across the evaporator or the heat exchanger. Okay, these types of assemblies, the motor is going to be attached directly to the blower wheel assembly on the shaft. The scroll cage is what supports the motor assembly in the motor shaft. Most of the time, what you're going to see nowadays, especially in regards to direct drive blower assemblies, they're going to be found in a lot of residential applications mainly. Some older furnaces out there will have belt driven, but a lot of our newer style stuff is going to be direct drive. Okay, your belt-driven stuff is usually somewhere around 1725 RPMs. Again, some belt-driven stuff, we do have the ability to increase the RPMs by adjusting the belt tension and the pulleys that are associated with it. These types of blower assemblies, the blower wheel is supported by a shaft and bearings. So there's a little bit more maintenance that is involved between these two. With direct drive blower assemblies, usually all we have to do is remove the blower assembly from the furnace, take it outside, and hit it with a little bit of maybe compressed air or an air compressor, get all the dirt and crap out of the blower wheel and off of the motor. If the motor has oil ports, we're going to oil the motor, oil the bearings on the motor, and then put everything back. Belt-driven stuff, we have to do a little bit more. We have to inspect the pulleys to make sure that they're not worn. Some cases we're going to have to oil or grease the bearing assemblies that are on there. We're going to have to make sure that the belts are aligned and not dry rotted and cracked. So there's a little bit more to it. We do have, again, the ability to adjust the RPMs by setting the pulleys and the size ratios of the pulleys. And these are often more likely going to be found on your older residential stuff and definitely going to be found on your commercial industrial type equipment. So here we are. We have an adjustable pulley. So a lot of times if we run into issues with furnaces not achieving the proper temperature difference or temperature rise across the coil or a heat exchanger. Sometimes it's going to be the velocity or how fast the blower is actually spinning. So what we sometimes will need to do is we're going to have to change the fan speed to slow down the velocity or increase the velocity. So in order to do that, to increase the blower speed, we can sometimes improve the flow of warm air through your home, or hell, even cool air through the home. And to decrease, it can also make the system quieter. Okay, so sometimes noise is associated with velocity. You can increase or decrease your blower speed by slightly adjusting the pulley on your blower drive motor. To increase it, what you're going to do is you're going to loosen the little set screw right here. And here's my little set screw. It's an Allen key. You're going to loosen that little screw, and then you're going to turn your pulley inward, okay, and about one turn. Okay, if we look at this picture, you can kind of see how we have some threads right here, but if you look right here, we have a flat spot. On adjustable pulleys, there's going to be a flat spot on this adjustable hub that is here. The reason why that is here is because that set screw needs to sit right on that flat spot. If we were to adjust this and take that set screw and hit it right on the threads, we are going to damage this pulley. So anytime you are adjusting a pulley, you need to make sure that that set screw is aligned again with the flat spot of that hub. Okay, so again, to increase your blower speed, you're going to loosen that set screw and you're going to turn that pulley clockwise one turn. You're going to actually close this gap between these two. And then by doing so, the pulley is actually going to make the belt sit slightly higher inside the pulley. And then by doing so, you're able to actually increase your velocity. Okay, and once that's done, you're again going to tighten that set screw. You do not have to kill it. You do not have to over tighten it. It just has to be snug, just so that it doesn't move. And if more speed is desired, we can again loosen that set screw, turn it in a little bit more, even a half a turn if you have to, and then retighten it. Okay, to decrease your blower speed, loosen the set screw. That holds the pulley on the drive set. Move or turn the pulley counterclockwise on the drive shaft one turn, and then tighten the set screw again. If less speed is desired, loosen it up a little bit more. And by widening the pulley, you are now making that belt that's sitting in there sit lower into the pulley, and that will decrease your speed. So, your blower speeds. The blower and motor pulley can also get out of alignment, especially if you're dealing with belt-driven stuff. And this causes the blower to be noisy and cut down on the efficiency of the distribution system, our ductwork, and the ability to deliver the air. So to check the alignment, we want to maybe place, we can use a carpenter square against the outside of the motor and the blower pulleys. And the pulley should be in a straight line and at right angles from the motor shaft. As you can see in this picture here is what we are talking about. Okay, if the pulleys are not lined up at right angles to the motor housing, loosen their set screws holding the motor pulley and move the pulley backwards or forwards as needed to align it properly. If these two pulleys are not in alignment, as you can see right here, this belt is actually in perfect alignment. This belt will actually dry rot. This belt will crack. and it will also wear down the pulleys. So the best way to check to make sure that both your pulleys, your drive and your driven pulley, your driven pulley is what is connected to your blower, and this is your drive pulley, which is actually driving the belt to spin, is connected to your motor. You need to make sure that this is in perfect alignment. You can use a carpenter square if you have one. Some mechanics will just simply use a level and put a level across your driven and your drive pulley to make sure that they are in perfect alignment. I've also seen mechanics use actually a shoestring or a boot string or something like that and actually go across and make sure that it is in perfect alignment as well. So, but this is honestly the best way to check for perfect alignment is by using a carpenter square or some sort of ability to see if it's actually at a right angle. Okay, it's always important to remember that if you are dealing with belt-driven blowers and stuff like that, that the pulleys in the blower wheel and everything are in perfect alignment and are actually cleaned. Okay, any belt wear more than normal is more often attributed to an improper alignment of the pulley and the motor. So if you look at a belt and you kind of see that it is dry rotted or shows a little bit of like unevenness in its characteristics and what it looks like, check the pulleys. Make sure the pulleys are aligned properly. Also, if you see that, you might want to visually inspect the pulleys to see if they have uneven wear and tear on them. When you're looking at a pulley, the interior part where the belt is actually sitting should be smooth. It shouldn't have any sort of grooves or any sort of bumps on the inside of the pulley. If it does, the pulley is worn out and needs to be replaced. Also, we should be checking for temperature across our units to make sure that we are achieving the correct temperature rise or temperature difference between our return and our supply air. By doing so, we are also confirming whether or not the blower is at the correct setting or at the correct velocity. Okay, we never want to take a temperature reading directly above the furnace, right where all the heat is actually going to be accumulating, basically right here. We want to take that temperature reading a little bit further down the ductwork, and I usually recommend you're going to do it right at the very first takeoff or the very first run that's actually going to deliver into a room or something like that. That's the best place to take it. Do not ever take it right above the heat exchanger, as this picture is indicating. You are going to get a false reading. You are also going to run into newer motors, such as your ECM and your VFD motors. Okay, ECM stands for electronically communicated motor, and VFD stands for variable frequency drive. These are very, very common today in a lot of our new equipment that's out there. The reason why is because these units have the ability to automatically ramp up and ramp down the RPMs and velocity based off of the demand in the house. Okay, the speed of the motor is directly linked to the application and the volume demand of the home or place of business. Okay, they also can compensate for air blockage. Some really extravagant homes, businesses will maybe have air sensors throughout the ductwork today. Those air sensors are actually communicating with the air handler and the blower, and it will actually send the signal to rather ramp the blower up or ramp the blower down in RPMs to compensate for anything that may be blocking or disrupting the flow of air. Your variable frequency drive motors, remember what determines the motor, the speed of an electronic motor is the RPMs. So the frequency of the motor and the number of poles is what's going to determine what the RPMs are. And there is your formula right there. Okay, RPMs equals frequency times 120 divided by the number of poles. Now, is that something you're going to use a lot in the field? Probably not. Okay, it's something that is good to have in the back of your brain just to figure out whether or not you actually even have a motor that is capable of delivering the right amount of air to a space. With variable frequency drives, basically how these work is if we drop the frequency on a motor, we actually can slow it down. Okay, we can actually take a motor that's spinning at 3450 RPMs at full speed, and if we slow the frequency down to say about 30 hertz, we are now able to make that motor run at about 1050 RPMs. Okay, so these have nice characteristics. In fact, I think they're great. But we have to understand how they actually work. Okay, and if we drop the speed on a motor, remember we are also slowing down the volume of air being delivered. And as we slow down the volume of air being delivered, we are now going to change that temperature difference between our return and our supply air. So it's always important to take supply readings, return air readings, subtract the two to come up with a temperature difference or a temperature rise. Your ECM motors, the motor speed is controlled by inverting the voltage from AC to DC, and then it is sent to the motor in the amount needed for whatever speed is actually needed. With ECM motors, they are technically going to come in three parts. You're going to actually have the motor itself. You are then going to have some sort of circuit board that's connected to, or the ECM module, as we call it, is going to be connected directly to the motor, and then it's going to be having some sort of circuit board that's going to communicate with the actual air handler itself. Then those three will actually communicate with each other to come up with the actual amount of air and speed that is actually needed to deliver the space.